My name is Osherove, and in the past 5 years, I got to work at some of the world's biggest companies. 200,000. Yeah, I know. You know you work at a big company when it takes 3 weeks just to get a laptop. You know you work at a big company when entering time, you actually enter time about entering time, because it takes an hour. You literally had taken an hour to enter your time in a big company because the software sucks so much and the usability is just so horrible. Now, the people that built the time writing software are also huge companies. And somehow they were able to produce some of the world's ugliest, most unusable software with hundreds of thousands of employees. So this talk is going to be how do those things happen and how do we prevent them from happening? And specifically in terms of DevOps, I also got to work in a lot of small startups. I'm originally from Israel, and I got to work in startups from 1 to 10 people, then from 10 to 50, and all the way up to 200,000. And those companies included Siemens, AIG, Bank of America, and Dell. And there are truth or anti-patterns that apply once you get to a certain size. And a lot of it you can put under the word politics, but politics doesn't actually do it justice because it really is all about people at that level of complexity. So a little bit about, well, I already talked about myself, which is my favorite topic. But I did get to do a lot of different roles over the years, in the past 20-something years. From developer to CTO to director to architect to consultant to a lot of different things. So I got to see a lot from both IT side and development side. And the fact that there are sides already alludes to some of the problems here. So the agenda for this talk is going to be influence forces, understanding why do people do what they do or why they don't do what you want them to do. And once we understand that, we can talk about enterprise-related challenges relating to DevOps, adoption, metrics, teams and collaboration, and pipelines. But first of all, I want to make sure that you understand that it's very likely this talk will not make any difference whatsoever in your life. Okay? Most talks that you come and see in conferences do not make a difference. Because what happens is, you go to a conference, you see something, you say, oh, you know what, that's nice, that's a really clever concept. We really should be doing that, all of us at our company. And everyone agrees, the people in your team that sit next to you, we should totally do that. And then you go to your company, and reality hits you in the face and says, yeah, that's nice, that's really nice. Please go back to what you were doing and stop talking all these nonsense about changing things. I mean, it's really good that you went and you learned all these good things. And we're happy because we are devoted to quality. But please finish that code. We don't have time to write tests. But at least you got to see it at a conference. So it's like window shopping. But there's always a glass there. Do I sound bitter? A little bit? No, just, these are all based on my own personal failures and sometimes successes. So one of the things that I discovered, there is a book, I'm going to talk about it in a second, that talks about these influence forces. And when I started reading that book, it really changed the way I approach these types of problems. Because I used to, I actually wrote a book called The Art of Unit Testing, a really successful book. And, for 12 or 15 years, I've been talking about unit testing in conferences. And you know what's the annoying thing is that you keep repeating the same things. Always from the beginning. People come in, they want to learn about unit testing, they want to do test-driven development, and then the next year, the same people come in and they want to learn about unit testing and test-driven development, and then the next year is the same thing. Nothing changes. That's what I realized. Nothing changes. I can talk about this thing every time, every year from the beginning, and still there's going to be hundreds and hundreds of companies coming in and says, yeah, we were thinking of adopting that stuff. That sounds like a good thing. That thing from 20 years ago. We should really start doing that, right? I really like that course, we should really start doing that. And people bring me on to courses, 3- and 5-day courses, TDD, right? And they come out of the course, yeah, that's really good. And then they come in and they send other colleagues to the courses, but they don't actually implement it at their own companies. So this is exactly about that stuff. Because DevOps is really change. It's all about changing things, changing people's behavior, and understanding influence forces will give us, at least to me, it gives a checklist of what do you look for to actually make a difference. Because I can talk to a person about unit testing from now until tomorrow, and they'll just go, yeah, absolutely, and then they still won't do anything about it, and it used to really annoy me. Because I said, what else is there? I explained it to you, you agreed, right? You know how to do it. Why isn't it happening? And the same thing happens for DevOps related, and it's all about, in an enterprise situation, it's all about influence forces, as you'll see. Once we understand them, we can map specific challenges and things we see in day-to-day to specific influence forces and say, okay, to solve this problem, we might have to look at this area or these ideas. And then we can continuously experiment and influence things in different people, departments, etc., and actually see what difference it makes. And this is the name of the book. It's called Influencer, The Power to Change Anything. And what I like about that book is that these people have made these experiments and have been able to make differences from tribes in Africa to gangs in New York, from small groups to huge groups. And the framework that they use, I try to use it myself on a day-to-day basis. And it really does make a difference. So what do they talk about? The first thing that they say is, if you want to influence something, first of all, you have to have a behavior in mind. You have to be able to describe a person doing something that you want them to do something different. It's no longer just a feeling like we don't care about quality or we never pay attention to something. No. We have to be able to describe it. But to be able to find the behavior we want to change, we have to find a symptom. And the symptom is usually a feeling or something like that. For example, our quality is low, our releases take a long time, etc. And once we find out a specific symptom we would like to change, we try to find out the root cause, and that is using the 5 whys method. Has anyone here ever used 5 whys? Raise your hand if you did. For those of you who have never used it, you basically ask why 5 times. Yes, well, they ask 50 times. And eventually, if you ask why more than 5 times, you will very always likely get to the philosophical truths of the universe. Why? Because atoms exist, right? There's always like a root cause. Why do they exist? There's always going to be one further down. That's why you have to limit yourself to 5. Because otherwise it becomes, it's no longer about your job. It's more about, where am I? What am I? And then your boss says, you are fired. Okay? So you ask 5 whys, you come to a specific root cause. For example, we don't have, we have many bugs because, well, why do we have so many bugs? Because we don't check for them. Why don't we check for them? We don't have time. Why don't we have time to check for them? Because we are always focusing on X. Why are we always focusing on X and not on this? And so we come to a root cause usually pretty quickly. And so once we have a root cause, we can look at the core behaviors, the thing that we would like to change, right? If the core cause is, for example, if the core behavior is something physical that we can describe, we can say, when team requests permission to change the pipeline, the IT admin says no. That's a physical behavior. And why do we look for a physical behavior? First of all, because it is related to specific people. It's not a departmental thing. It's literally a person that you would like to change that person's behavior. Because eventually it's all about people. As we all know, there are no technical problems, there's always just people problems. The code always does what you tell them. Unless it doesn't, but that's a different problem. Ask Don. When release milestone arrives, the tech lead announces a code freeze. Why do they announce a code freeze? Code freeze is not usually a great idea. Why does the tech lead announce a code freeze? When the build fails, nobody on the team does anything about it. So you can say for each person in that team, when there's red on the screen, assuming we have a screen, of course, then that person does not do anything about it. And once I have a single behavior that I would like to change, I can try to understand why that behavior happens. And one of my favorite phrases from the book is, for any behavior that you see in the wild, the world around that person is perfectly designed for that behavior to happen, right? Because if you were that person, if you were in their shoes, if you had their history, if you had their boss, if you had their wife, if you have their dog, if you had their kids, if you had their experience and their history, you would have done exactly the same thing. So what is the thing that causes that behavior? Because it's that thing around the person that would like to change. It's no longer just about me convincing a person. Maybe that person is convinced, but something else causes that person to do something else. So the six factors, the first two are personal motivation and personal ability. Those are usually the things that we all try to tackle on a daily, day-to-day basis. Well, I talk to the person. He said he wants to do it, so personal motivation exists. Does the person know or is able to physically do the thing? For example, not announce a code freeze? Or is the person able to do pair programming? Are they able to come into the daily meeting on time? Are they physically able to do different things? And usually they are able to, and when they're not able to, at least we found out something that we can maybe change. For example, the person is living too far away, you might actually want to change the time of the meeting. But then we have 4 other factors that usually almost nobody thinks about on a day-to-day basis. And that is social motivation, social ability, structural motivation, and structural ability. And I'll explain what each of them is. Basically, the questions you usually ask is, think of it like a checklist. From personal motivation, does the person believe in the good behavior? Is the person physically able to behave well or physically avoid the bad behavior? For example, you're teaching a team about test-driven development, or you want the team to do automation. Well, there are 2 sides to this. People actually may not want to do it, or they want to do it, but they don't know how to do it. They're not physically able to do it because they don't have the technique. You send them to a course, right? If they don't want to do it, you have to actually talk one-on-one and find out what the reason is, which is rule number 1 when working with people. You actually have to talk to the person. But a lot of times, we are afraid of talking to people, so we play in our heads. Our brain catches us and says, you don't need to talk to the person. It's like a Jedi mind trick. You do not need to talk to that person. You already know what he will say. Oh, I know what he's going to say. I'm going to say this, and he's immediately going to say X. So there's no reason for me to talk to him. If you've ever said that to yourself, that's you. That's your brain avoiding having an interesting and tough sometimes discussion with a person. But it does start there if you want to understand motivation. Because some people have been in other organizations where they have bad history with the behavior you want to change. So maybe they don't believe it's a good idea. But let's say they do. Then we have group. How do the people around that person behave if they did the good behavior? What are the people that that person follows and believes in? What do they believe? For example, if the person that I want that person to do automated testing, but there's, an architect that he listens to a lot. And that architect believes it's a horrible idea to do test-driven development. It's very likely that the people that you follow, the people that you trust, what they think will matter a lot to what you think. If you've ever been in a conversation with someone and you disagreed, and then you ask the third party, hey, what do you think? Good idea or bad idea? And that person says exactly what you just said, but they didn't listen. But that person says, oh yeah, of course. And then the other person says, oh, well, I guess it makes sense. Like, I just said the same thing. Why didn't you listen to me? It's about trust. People that you follow can change your mind very easily. So if you want to change their mind, maybe you find someone else that they respect a lot that thinks the opposite. Another way to think about it. If I'm the only person, and let's talk about social ability. If I'm the only person doing unit testing or TDD in the group, and everyone looks at me funny when I do it, it's going to be very difficult for me to continue doing it. Or the other way around is, if I'm the person in the group that's always negative, that always says it will never work. On the daily stand-up, I always question everything, and nobody does anything about it. Nobody tells me, look, just stop, this is annoying. Nobody in the team ever says anything. Everyone expects someone else to do something. That also enables a specific behavior. So if you have a specific manager that doesn't allow X, but X is a good idea, getting other managers to think it's a good idea to actually listen and say something, sometimes and interject, is a good way to start moving things forward. Sometimes group is about building a small community inside the company. For example, a small meetup or a user group inside the company that believes in specific things. So then even if the person is alone, they don't feel alone because they're alone here. But in another department, there's another Lone Ranger and another cowboy in another department. And we're all together believe in these core values. But now I'm not alone. Now I'm like a hero because I think this is a great idea. And every week or two, I meet with a bunch of people that think the same way. And we discuss ways on how to accomplish this. So I have strength in numbers. So if we want something and we have a kindling, just a small movement inside a company that wants to do the right thing, one of the best ways to make the flame higher is by convening a bunch of people that believe in the same idea on a daily basis, even if they don't work together on a daily basis. Not daily, on a weekly, sorry. But even if everyone around you thinks it's a great idea, and everyone you follow thinks it's an amazing idea, still you might not do the thing that you would like to do. Because then we have the company, the environment. What is the reward structure? What are the incentives in the company to do the right thing or the wrong thing? If everybody says, yeah, we want to do TDD, but you know what? I get a bonus at the end of the year by shipping faster, not by quality. My metrics are about stability. They're not about change. If I'm measured on how much my build fails, what am I going to do? I'm going to make my build not fail. What's the best way to make a build not fail? Not check in, right? What's the best way not to check in? Make a branch. Just work on the branch. And maybe every 2 or 3 months we'll merge into the master branch. But we'll be really, really, really careful. So we're going to run this whole other pipeline in parallel. But the master branch is 3 months behind. So the applications we deliver are basically 3 months old code. They're not the newest code. So that also means if I want to make changes, if I want to fix bugs, it's going to live for a long time in those other branches. If I'm afraid to break the build, because I'm measured on how many red builds I have, that's an example. Same thing for code coverage. You want code coverage. You got code coverage. You say to the developers, we want the highest code coverage possible. Huge mistake. Huge mistake, because code coverage, 100% code coverage doesn't mean anything. It's meaningless. But 10% code coverage, now that means something. It means what? Any ideas? What does 10% mean? Well, kind of. It means you're missing tests. 10% code coverage means one thing only. You're missing tests. 100% code coverage doesn't mean anything. Because I don't know what your tests do. Do you actually have asserts in them? Are you actually, or did you just write a loop that covers all of the classes and execute them because you're measured on code coverage? And I've seen companies do that. Because it starts out like a great idea, but then the team lead comes in and says, okay, folks, look, we need high code coverage. Management has really put that on a pedestal this month. So we should all really work on code coverage. Let's write a bunch of tests. Everyone goes, yeah, let's write a bunch of tests. And maybe they even do pair programming. And then in the pair programming session, one person goes to the other, hey, I have an idea. Let's just do just run through the thing. You don't need to do the assert. Just execute the whole thing. We're going to get like 50% code coverage in one day. That's awesome. Because the metrics, how we are measured, change our behavior. So if we want to change behavior, changing metrics is also very important. And in a DevOps world, the metrics make all the difference. Here's another example of a metric. Mean time to failure. Basically, how long is the application stable? 999.999, etc. The longer it is stable, the better you're doing. So then my developers are all trying to make, continuous delivery, continuous integration, commit, push into the thing, and then the IT folks are right over this line. They go, yeah, that's not going to happen. We have a clear release date in 1 month. So all of your builds do not matter to me because I'm measured on stability. which means I want as least changes as possible in production, right? So now I have IT administrators and operations basically fighting development because they're trying to achieve the opposite goals. So we'll talk about better metrics for that. And even if the company rewards the good behavior, and even if you had all of those things working for you and the metrics are fine, there could be physical environment problems as well. The physical environment you can touch and feel. For example, you want everyone to do pair programming, but you have those desks. You know those desks that have a corner in the middle? So only one person can sit in the middle of the desk. It looks like this, like a half donut. So a person can sit like this with monitors around, but if you wanted to pair program with a person, you have to sit like in the corner like this, like an idiot. Can I have the mouse? Like this. Physically, you're not able to pair program. So of course, the best way is to flip the table or get these tables. These are pretty good tables. So the physical environment makes a difference. And also where the team is. You want the team to meet, but you have one team here and one team in a different country. That's an example of physical environment that's very difficult to change, but at least you have to take it into account, because physical environment also means different cultures. And different cultures also means sometimes different metrics and different sets of values. Okay, is that complex enough so far? Okay, so this is the way it appears in the book. If you want to start changing these things, well, from a personal motivation, you want to make something that's undesirable, desirable. You want your kids to clean up the room, you make it into a game. You have that trick? I have three kids, 3 boys, they're crazy. And when I want them to clean up the room, I say, you're not allowed to pick up any toys. But if you are going to have to pick up toys, then we're just going to have to, to start the movie sooner. But please do not, just continue playing. We don't have time for a movie anyway. Just continue playing. Just change the incentives. Or make it a game. 2 points for each toy raised. What are points? Nobody cares. Nobody cares. I got 1,500 points? Yeah, because that's a big toy. So you get 1,500 points just for that toy. Oh, I totally win over my brother. So that's an example. And then we have ability, surpass your limits. This is where we're talking about teaching new skills to people. When we're talking about self-organizing teams, those teams need to build their own skills and learn how to work in new ways. This is what we're talking about here. Then we have social. Harness peer pressure and find strength in numbers. You don't want to be alone when you're doing something, and you want to be able to have peer pressure to observe the right behavior. An example is, if you came into a company tomorrow, you're a new developer, came into a company tomorrow, and everyone was doing TDD. It's not even a question. You start with a test, everyone just assumes that this is the way you're supposed to work. And you don't think it's a good idea. Are you going to say anything? Are you going to not do TDD in that company? It's going to be very difficult. There's an experiment, you've seen it. People come in to an elevator, a person comes into an elevator, and everyone in the elevator is an actor. And everyone in the elevator just turns around to the opposite side of the elevator. Instead of the door, they face the wall. And the person just stands there, looking at all the people facing the other way. Says, oh, I guess I'm going to face the other way too. Just because we want to meld in, we want to be part of something. And then we have to design rewards and demand accountability at the company level. If we're not going to change our metrics and our compliance and our policies and all that stuff, it doesn't matter how much we want to change, because the rules in the company say one thing and the behavior we want says different, and the physical environment. So treat it like a checklist. It's not a recipe that for every one thing you have to change all these things. But do consider that for a single behavior to change, you might have to change multiple of these. You might have to talk about motivation and teach, and also change this and also change this. You could have 6 factors applying on the same person for that same behavior. And you have to fix all of them before that single behavior changes. It only takes one of them to bring the wrong behavior back. So sometimes we'll say, well, I sent them to a course. Why doesn't it change? Because there are other factors that we're not considering. So it's a nice checklist. When I'm stuck and I'm not sure what to do, and I say, why is that person doing that thing? The last thing I should do is to say, well, he doesn't care. That's wrong. I shouldn't say, well, that person's lazy or he doesn't care about the project. That's not true. Every person does the thing that's the world around them is designed for. And that's basically it. That's what we're trying to understand, like Sherlock Holmes. So let's look at enterprise challenges from that perspective. In enterprise, in a big enterprise, we start to have multiple different projects, sometimes thousands of projects. So we have interdependency between different projects. You break one project, you can break 5 other projects. You institute an update, you can break a different project. We have a lot of times monolithic applications. We have a lot of approval gates, change control boards. I was working at a company in Norway, and we really wanted to, have automated testing, and we wanted to work with Selenium, but we needed to open a firewall rule in the company to be able to run those tests. And we had to wait for every second Monday, because that's when the firewall rules are allowed to change. So there's always this, twice a month, there is a firewall committee, and that's just the way it is. There's nothing you can do about it, right? You can bitch and moan, you can say this doesn't work, but this is the policy in the company. You want to have a security person. Nope, there's 3 security people, there's 20,000 people, 3 security, and they're not even in your country. What are you going to do? How are you going to get security to approve an automated test that does security in the pipeline? And we have compliance, which of course, it sounds like compliance is like this whole different organization, and it is, but it shouldn't be. It can be a part of, in a DevOps process, it can be and should be a part of our pipeline as well. And then, of course, we have the old processes, the waterfall-based processes. We have to adjust them into this new world as well in some way. And we have a lot of manual and error-prone processes that are done at the team level. So these, for example, would match, a lot of these match exactly structural motivation and structural ability. These have nothing to do with personal motivation, personal ability of people to do the right thing. Even groups, the social ability of people to do the right thing has nothing to do with them. You're coming into a situation that is physically difficult, and also in terms of rules and incentives, pushes you in exactly the opposite of where we're trying to go here in a DevOps world. So it sounds like this is a losing battle. And at the beginning, if we don't understand this, it will be a losing battle. A lot of different change initiatives fail because they try to not look at the big picture, they try to look at the small picture and say, well, we're not going to touch the whole thing. Only in our small organization, we're going to do our own little bubble where we do continuous delivery and we do all that stuff, all the way up to the end of the bubble, and this is where the real organization begins. And then we have to deliver this, and we have no idea, and we do not want to know what happens there. And after this, what really happens is that all of these other groups come in, and they have their own processes, and they recompile your code, and they do everything manually, and it's just a horrible, horrible parallel reality. So it kind of makes sense you want to get away from it, but it's the anti-pattern to get away from it. The real success pattern, because I'll just explain why it's an anti-pattern. It's an anti-pattern because if you create your own bubble in a big organization, the only thing you're doing is you're going to basically recreate different processes and policies inside your own little small organization, which do not match at all with the overall organization. There will be a time, sometimes it's very close, sometimes it's a few months after, where you have to interact with the outside organization, and the more difference there is, the more clash there will be. And then the politics really start. Why do they have different tools than us? We are the ones who set the rules, right? Why they are doing all this stuff, I don't understand it, I don't care what it is. We have process here. So I don't care how well you test it, I'm gonna take your code, manually compile it, manually test it, even though you already tested the whole thing. I will do everything the old way because that is the old way. Did you share any information with me? Did you teach me how to do the things right? No. Did I ask you? Of course not. But that's part of the problem, because in an enterprise, getting those organizations to talk is part of it. So let's say that we want them to talk. Who do we ask? The managers in the organization. And if the managers do not want to talk, that's a behavior that we can measure. We say, when we want to discuss with organization X, manager Y says no. That's a behavior. And then we can look at it from that checklist. Because then we can start changing and saying, how can we, or why does that person say no? Is it a process? Is it a risk? Is it a specific thing? And then we can start to look at it almost from a scientific way, a scientific method. So if DevOps is change and it's human behavior, one of the biggest challenges is transformation at the organizational level. And one of the biggest anti-patterns is Big Bang DevOps. Managers feel like they're just going to start the DevOps, they'll hire a big company like Dell or IBM, pay them millions of dollars to do a transformation. Thousands of applications and this assessment, and I've been through that stuff. And then they'll say, okay, we have a start and we have a finish, and when we finish, it's just a amount of throwing time and money on it. When we finish, we have DevOps. So give me 3 DevOps and 2 milk, please, to go, right? It's like, and I need 5 more DevOps tomorrow. What is DevOps, right? It's usually an anti-pattern. You have DevOps people. But we have to start transforming somehow. So the managers come in and they give the plan to the entire middle management, and middle management goes, absolutely. Yeah, I think this will work. This will absolutely not explode in our face. Because everybody knows when that happens, like, there's no way in hell. We've all been through some of those projects where on day one, you knew the project will fail. It's just a death march. Well, we're going to fail anyway. Just say yes so we can go home and watch Game of Thrones. And then, of course, they start. And they go, okay, I'll do the testing. And the tester says, no, we don't have time for testing, but we need to do continuous delivery. But we don't have time to automate. Okay, but we need a pipeline that also does the automated security. And the security person goes, yeah, not going to happen, not on my shift. And the compliance people go, no, you have to go through all these steps. And everyone goes, you wanted us to do X. And all these people are telling us we cannot do X. And the whole thing explodes. So immediately there's panic. People go, abort immediately. 2 or 3 months into the process, everything goes back. Because when people panic, they go back to what they know. And a lot of times, people are great at fighting fires. They're great at being the heroes in a horrible process. They're great at fighting something until 2 in the morning to debug, because everything else sucks. So they're used to the old process. And sometimes even those people do not want it to change, because this is what they know, this is what they're good at. So it's very easy to abort this thing. A better way is to do it, of course, mildly, incrementally, small pilots. And in those pilots, we focus on one thing: teach people new skills. Because the thing that really broke down, or part of the thing that broke down, is that nobody knew what the hell they're doing in the Big Bang transformation. So we do these pilots, and these pilots can take sometimes just a few weeks. We take small applications, and those applications will try to achieve full CI/CD pipeline, but only for that specific application, or even just a component of an application. Sometimes it's even a parallel team, because then it's less risk to the organization. And of course, that team is going to go through what everyone else would have to go through, and that team is like the messenger team. They go out and they tell you all the problems that you're going to face, and then those problems are the things that you actually have to solve. So that pilot team will take in most of the damage from trying to get something all the way to production in this organization. There's going to be a lot of stuff there. Another anti-pattern that happens a lot is that we have adoption, but it's only one-sided. For example, technical leadership pushes for, let's say, DevOps change and transformation, but upper leadership does not believe in the same ideas. So we have technical people trying to push something, but we do not have air cover. We do not have support of management. So when these people actually try to achieve the things, and they need to change the rules for those things to happen, management goes, yeah, why? No, everything worked great. No. If we want to be able to make a change, we sometimes have to change the rules of the game. Because the rules are that structural ability we talked about. You're not physically able to do it because it's not allowed in this company. There's a law in this company that you're not allowed to touch production servers. So we need air cover for managers to say, it's okay, he's with me. I want you to give that person a one-time pass because we're doing a pilot team. And for that pilot team, we're changing the rules because we're experimenting with the rules. So for everyone else, everything should still suck. But for that pilot team, we're doing an experiment with a set of different rules that will allow continuous delivery. So that bidirectional support is the incentives and the processes. And sometimes it's really about enabling people to do the right thing and actually have air cover. You had a question? So Dennis made a great and very, very optimistic point. He said, most of these pilots are eaten alive by the immune system of the organization. And part of it is exactly that. It's exactly about middle management supporting the thing and upper management having at least one sponsor that can fight for you inside the bowels of the beast. And it does not happen successfully if you do not have a link from the top to the bottom that you can escalate problems. Because if you cannot escalate problems, at some point you're going to come into a middle management that says, well, that's it. I was your sponsor. But that person who just said no, he is a higher level than me. And that's where they are stuck. Okay, policy. Let's talk about policy, because policy is one of the biggest eaters of these changes. Because no matter what, no matter how much everyone is involved and loves to do this stuff, eventually you have organizational policy. So let's talk about a simple and standard DevOps workflow, and I'm sure everyone here has exactly this. At the top you have development, at the bottom you have operations. Development works on code, commits and builds and validates and deploys the application. In parallel, operations has their own code, infrastructure is code, they commit, they have automation validation procedures, basically fully automated test for infrastructure. They deploy the infrastructure where the application will be deployed, and this all happens just in time. And then we have acceptance tests, capacity, and a bunch of different stuff where if we pass, we can actually destroy the test instances and just deploy to production in one of many different ways. This is like an example of a skeleton of a parallel pipeline where usually you would want to aim for that. But where is the policy here? I mean, if we think about a pipeline, what is a pipeline really? Each step in the pipeline is an example of a test. A pipeline is just a series of tests. That's all it is. If you started here and you went past all the way here, then you come here and you pass the test and you are able to deploy to production. A pipeline, eventually, what we want it to be, is the organizational policy of production. This is our actual policy as code, if we think about it like that. So the policy, really performance, security, all of that stuff comes in as part of the pipeline. Policy, like compliance and security, would just be extra steps inside the pipeline. And they could be running in parallel. All the various different steps. What we want is for all of these steps to stop being manual and start being automated so that we can put them in pipelines. And of course for that, remember we're talking about just a pilot team here, because we are working incrementally. We create I call it a tiger team. Well, not me, the person I used to work with called it a tiger team, and I like the name. The tiger team, or a CM, or configuration management and policy and standards tiger team, is a team dedicated to the pilot. And it's a team made up of all the people that are related to compliance and security and whatever you need from the organization to change the current standard protocols. And they're going to create again, a one-time continuous integration and deployment policy for DevOps. They're going to create a new type of policy that allows all that automation as an experiment and only apply it to that specific team. All the other teams would use the old ways. And what they're going to do is they're going to learn what does it take. A along with the pilot team, what does it take? What does it mean to automate the thing that we used to do manually? And it could take sometimes months to figure out, because it's really about interviewing people and talking to them and saying, well, how do you do compliance checks? Now, in big organizations, usually developers will have no access whatsoever to these people. They will not even know what are their names, even know what department, that there is a department. It's a complete black hole. And here we're talking about developers and compliance people sitting together and trying to come up with a good script that represents what they're doing manually in some way. And slowly and surely, this is possible, because a lot of times the checks that they do are pretty simple. Do you have all of these documents? Are all these things checked? Did all of these things pass? Of course they passed. We have full auditing from the log of Jenkins or TeamCity running, so that's actually easier to have a check that does all these things. Same thing for security. Security already does automated testing. They just click a button to do it. So we want the pipeline to click that button for us. So this Tiger team is key, because they allow us to change the rules and change the incentives for that team. Basically, give them permission to do the right thing. Here's another thing that happens a lot when we do DevOps implementations, is that people focus on the wrong thing. They focus on trying to change and optimize things that bring less value. And this is where value streaming comes in. One of the things that I teach people that I work with all the time is that before you even start any kind of implementation, before you change anything, figure out what is the current state of affairs. What do you currently have in your organization? Because that is the baseline. This is where we start. That's how we know that we've actually made a difference. And one of the best ways to do it is to find out the full cycle time from the moment a request for a feature is received until that feature is actually running in production. Now, for each team, for each project, you could have different steps. But it's really about sitting in a team of all the people that it takes to deliver in the room, from security, compliance, project management, development, testing, architecture, UX, doesn't matter. Everyone who's involved in that specific application, and really sitting with a whiteboard and a bunch of sticky notes, and maybe for 3 or 4 hours, hashing out the full cycle, including how long things wait to be able to be started, and how long does it actually take for something to be finished. For example, imagine that instead of, I'll just say that when you start this, people will say, when you sit with people in the room, they'll say, well, we don't have to measure this because we have a release every 3 months, so it always takes 3 months. That's not what we're looking for. What we're looking for is, what if you took a single feature and you put a GoPro on that feature's head, right? What does that feature see from the moment you put that feature into the request pipeline, right? So the feature will say, well, I sit there for about 3 days until someone touches the feature, and then they work on me for about 30 minutes, and then I wait for another 2 weeks for the architect to look at it, and then they work on it for like 3 days, but not 3 days. They work on me like maybe 30 minutes in 3 days, because they work on a lot of different things. And then I sit there for another 2 weeks. I wait for the budget. And then on the budget, that takes there's this meeting, there's this, and you look at that, and that is the cycle time. Well, I sit there in the development team, and someone takes it, and they work on me on average, let's say 3 hours, but then I wait for the end of the iteration another week and a half. Okay, interesting. And then the testing team comes in, and they test. It only takes about 10 minutes to test me, but I still wait for the end of the testing cycle, another let's say 3 days. So I'm just sitting there waiting for 3 days, even though technically I work. Okay, interesting. So then we have these two different types of work. We have actual work, and we have waiting time. And the waiting time and the actual work come into a specific percentage, and this is the percentage of actual effectiveness that the team or the project or the organization has. And then that is the baseline, and we always take the average idea. And this average, let's say that for every dollar that you spend on the project, you get 15 cents back, as an example. 15% of the time is actual work, and the rest is waiting. This is what it takes a feature. So even though our release is 3 months, a feature could be in the pipeline for 3 releases. And this is usually a very interesting realization for a lot of managers. Okay. So even though we are running in sprints, a feature can actually take 3 sprints to finish. Interesting. So the time it takes from the moment I have an idea to the time it's in production can take a year, even though I have 3 months releases. And that's an important number, because that is the number we eventually want to be able to change, the cycle time. And from that, we can start to gather which of these things we want to start changing first. And sometimes it's not the thing we thought it will be. This is an example of an Excel file that I usually use, where we literally just put in the different handovers that happen in a specific company or project, the time it takes, there's also parallel time, etc. And we put numbers at the end for how many days, months, and weeks everything takes. So the full cycle time is the accumulation of all the numbers at the top. Okay, metrics. So this is a very common thing. I started talking about metrics before. We want to make a difference. We have to change the metrics that we use. One of the most obvious glaring offenses for metrics that I see it, and it's like I cringe when I look at it, because this makes the exact opposite behavior of what we want. Red is bad, coverage is good. Okay, if I see a red build, and look, I used to teach the exact opposite. I used to teach exactly that, hey, you know what, when you get a red build, you get a special t-shirt, and you get the person who broke the build a special t-shirt says, I broke the build, ha ha ha. Everybody laughs, it's fun. And whoever breaks the build puts some money in a jar, ha ha ha, we're all having so much fun. Well, what happens? Red basically becomes this thing that everyone wants to avoid. It's the Antichrist. It's the thing, oh, a red build, I'm afraid of breaking the build. But builds are meant to be broken. They're supposed to give us the feedback. If we don't actually break the build, how do we know that everything is okay? It's like saying, I'm afraid to compile, because I don't know how many errors the compiler is going to give me. No. We have continuous compilation today, right? You write a character, you immediately see everything in red if there's something wrong, and you're happy with this. And your compiler can give you hundreds of errors a day, but eventually you're going to get the code right. You're going to put that semicolon / question mark in Roman numerals, I don't care. Eventually you're going to get it right, but the compiler is there to support you. And the same thing for builds and pipelines. They're meant there to see the latest version of your code from everyone and try to integrate it for real and actually fail. And it's okay, as far as I'm concerned, that a build fails 80% of the time in a day. You can have, let's say, 50 builds, and 40 of them fail, but 10 of them are green. What it means to me is that when it's green, it's shippable. That is the real shippable code. Because what happens when I'm afraid to break the build? I won't check in my code, right? I won't check in my code. The build is green. It doesn't mean that it actually has the latest version of the code. So the build is actually lying to me. Just because it's green doesn't mean it works. Because I have code in this branch that would actually break it. I have no idea, because I don't have the feedback. So I'm okay with breaking the build. Now, we have different stages. We can have gated commits that run the build before you check in. That's great. But eventually, you do want to run the build as many times as possible. And for that, we want to be able to change the metrics. We talked about coverage, why that sucks. So here's my metrics. I don't mind that you have red. If you have good code coverage, I will suspect that something weird is going on until I do code reviews. So coverage only means something if you also have code reviews where the reviews are also done on the tests. If you do not have code reviews, coverage is meaningless to me. And this is a metric that I like to use for teams that do continuous delivery. I will measure time from first red to first green. I'm not measuring how much time of green you have. I'm measuring how much time of red you have. I don't care that you have red. I just want to measure how long it takes to get from red to green. And this is also the technical term for this is mean time to recovery. That is the DevOps metric of choice. The same thing should apply also to IT, to operations. Mean time to recovery gives you exactly the behavior we want. It's okay that it's red, but if it's red, you better be doing something about it. Because if it's red for a long time, something is wrong. If it's red for a long time, it means maybe nobody's working on it. Maybe it means that it's very difficult. There's this huge complexity that we put into the code. So eventually what we want the team to react to a red build, and we want them to do something about it. For example, create a cycle where every day a different person is responsible to look at a red build and immediately take action as a first responsibility. And the same thing for operations. I don't care that we have production deployment issues. All I care about is what happened when I have a production issue. How long does it take me to get to a stable one? I don't care how long the stable one is. I mean, I do care, but not as much as how much it takes to get there. Because the thing that I really care about is, again, I care about how resilient is the code that we write, how resilient is the infrastructure that we write. And if it takes a long time to take an application from red to green in production, it means that I'm going to be afraid to put a new application in production. And the faster it is to get it from red to green in production, the easier it will be and the less scary it will be to push a new application to production, because maybe it's a feature flag or anything like that. I can just flip a switch and the application will go back to green. So, for example, I will have to learn as an operations or as development or as together different deployment techniques of deploying in parallel, of doing canary deploy, of doing small rollouts, etc., that will allow me to go back from red to green if there's an option. And that also dissolves my fear of deploying to production, and suddenly myself and the development work together on the same vision, which is continuous deployment instead of fighting against it. Okay, we have about 10 minutes. One of the, there are 4 main DevOps metrics that I would recommend to use. Lead time to change, that is basically our value stream. Release frequency, we want to see that basically go up. The defect rates will go down, or we want them to go down, and mean time to recovery versus mean time to failure, which is a very common operational metric. So these metrics will lead or push the organization into that right behavior. Because in many organizations, what happens is that people are measured not on release frequency. They are sometimes measured on defect rates, but the release frequency is not measured. And then what happens is that there is a big focus on quality, but that actually makes the releases much longer because a lot of things are done manually, etc. So if you don't also measure how fast or how many releases you do, you can basically lose the entire cycle time just because there's this focus on quality, which is okay. It's good to have focus on quality. But if you actually also want to have automation, etc., you should measure how long or how many releases are we able to do. Why are we not able to do that? That's that 5 times. We will reach a lot of times those right conclusions, and then we'll start changing the behavior. So if management makes those metrics available, not the team lead, but management says all technical leaders are now measured on these 4, right? I don't care if you're QA or not, work together, figure this out. A lot of times, this is sometimes the push they need. And of course, the next thing they're going to say is, yeah, that's great, but we don't have time for that stuff, right? Because that's one of the main things. And this is, again, structural, but I will say specifically about time. Actually, I'll just jump to this. We have this problem, right? We don't have time to automate. We want to do the right thing, but this is one of the only things that does not fall into organization or physical environment. I know it sounds like we don't have time is not my problem. My organization is supposed to give me time. But that's not true. As far as I'm concerned, that's not true. Because the people who estimate are the people who make the time. And the people who estimate are the developers. And when someone asks a developer how long it takes them to build something, and that developer gives an estimate that does not include quality built in, it is nobody else's fault but that developer. Right? Because what happens is, if we don't include that quality built in, we have this. We don't have time to automate, so we have more work added because every time we have new features, now we have to do a lot of manual work. And of course, because we do all this manual work, we actually have even less time to automate. And it's a very downward spiral. The less time you have to automate, the even less time you'll have to automate in the next iteration, etc. Because you don't automate, right? If we did automate, we will have more work, but it will be automated, so we won't have to do all that manual work, which means we will have even more time to automate. It's the opposite spiral. But having more time to automate, where do we get that more time? It's up to us. You know that triangle? Everyone saw this triangle, right? You can either choose features, time, or quality. You can only choose two. I think that's wrong. I think that if I'm a professional and I work on code, then quality is not optional at all. Just like debugging is not optional. I don't say, well, it's going to take me 3 days without debugging or 5 days with debugging. Sounds ludicrous. Same thing for testing and automation and quality. Because this is supposed to be part of the initial job. If I buy a car, they don't say, do you want it with or without wheels? No. Quality is non-negotiable. I don't care. You hired me to do a good job, right? I'm a professional. When I do something, I do it the way I think it should be done, which is also with testing. I don't ask for permission to do it. I just give you an estimate that includes it. So my estimates sometimes will take 2 or even 3 times more than other developers, let's say. But if all of us, right, if all of us did the same thing, if I'm the only developer giving really high estimates because I'm including quality in, I'm going to stand out like a sore thumb. But if the whole team decides to make an estimate that includes quality in, then all of the estimates make sense. And here's the thing. Everyone that asks for the estimates, project management and anyone, product owners, the estimates are the thing that decides the trajectory of the application. Nothing else matters. At the end of the day, it either takes 3 days or it doesn't. So the people who make the estimation have the power to change this. Nobody else. You do not ask permission for managers to include quality in because they don't know how to do it. You know how to do it. All you need is time, and the time is the thing that they ask you, how much time do you need? They literally ask, how long will it take you to build this? They ask you. So tell them. That's all. The power is in our hands. It's nothing to do with structure, but we believe it is. We give them the permission to remove it because we've always done it. But I think these are new times, and we're supposed to stop doing it. Okay, choosing tools first, and then we're going to finish. This is more of a personal ability, but also structural policies. In many organizations, the teams want to build pipelines, and then they have these tools imposed upon them that don't match the pipeline. The pipeline needs to be automated and all that stuff. Oh, but guess what? We have to use SAP and log into this just to be able to have a release. We have all this horrible different tooling just to be able to do something, and it's not automatable at all. But it's already decided for us. So if you want to be able to change it, we have to understand the tooling landscape, and there are many, many different tools. But if I was going to change it, I would go to the people who make the tooling decision in the company, and I would teach them about these values. From now on, at the company level, no tool goes into the company asset store, into the license store, if it doesn't answer at least all of these things, because we are a pipeline-based company. It has to be in some way, scalable and parallel. We're talking about development tools, right? Scalable, parallel. Imagine stuff like Sonar, Cube, etc. I've seen companies that implement it, and you can only run one at a time. So all teams have to run with it and wait for all the other teams, and it takes 1 hour, right? So speed, of course. But we also have source-controlled configuration. Does the tool have it or not? It's automatable by other tools using command line. It has an API, so you can see the results. So the pipeline can run the tool. These are pipeline-based values. So we put this at the company level, at the policy level. And a lot of times, companies are just not aware that this is hurting. So the people who make the policies about tooling, it's all about personal education, and then they can also make an educated change to the company policy about tooling. A lot of times, that's one of the easiest parts. Because these people, they already care about these tools. They just need to learn about these new requirements. So in summary, the influence forces, to me, are today the key to understand why something is not working. Of course, this applies to DevOps, but not only. It is a key to understand any human behavior I'm in contact with at a company, when people that I'm not related to, because then I actually have to talk to them. What about a checklist? If I approach something and I'm stuck, I have a checklist. I said, okay, I have no idea what's going on. I guess I'll go back to my checklist and say, what did I miss? What am I not thinking about? What is that person thinking about? And I literally make my own little table and say, well, I think this one is like a question mark. I think I should check about this. Well, I wonder what the other people think about this. And it gives me a checklist of where to approach things. And then I can continuously experiment with my own personal team that I work with, etc. We've had a company experiment by literally saying there are no QAs anymore. All QAs learn development. There is no manual testing anymore. Physical, it's not allowed. Right? And of course, the teams were like, I don't know what to do anymore. And then they were forced into this, jump into the pool and start automation. No other way to do it, because those teams were covered by manual testing up until that time. So after about 2 months, the teams were like digging themselves out of the hole, but they were in a much better position for a DevOps-related solution. So that was an extreme example of an experiment. But it's an example exactly of how company and structural and social make a huge difference to actually change behavior, even if it's a big organization with a lot of history. So thank you very much, and hopefully this will make a difference. Thank you.